Hello, everyone. Facebook, Instagram, and WhatsApp experienced a 6 hours outage on October 4th for 6 hours. I'm sure that some of you, like me, had a very good sleep on October 4th after a long time, right? And some of you must be busy turning on and off your data. Well, 6 hours later, Facebook restored services across the platforms and blamed the outage on a configuration change on routers that coordinate network traffic. So everyone, good evening. I, Uddipana Goswami, welcome you to our SKC Science and Technology webinar series. So as you all know, today we are going to talk about a recent global outage across the social media platforms, Facebook, Instagram, and WhatsApp. To discuss the topic, we have with us the founder of SKC Webinar, also Program Director, National Science Foundation, USA, and Distinguished Professor, University of Missouri, Kansas City, Dr. Deep Medhi. I welcome you to our webinar. Today, I'm your host. Always you host our webinar. So now I request you to give the brief introduction on the topic. And I request everyone to go on mute, and time to time, you can type your questions on our chat box, and at the end of the webinar, not at the end of the event, you can type your questions, or you can unmute yourself and ask your questions to our guest. So yes, now we can start our webinar, and you can, Professor Deep Medhi can start the presentation.
Thank you, Uddipana. Can you hear me all right?
Yeah, I can hear you.
Very good. All right, great. All right, so this has been a big news on October 4th, as Uddipana said. In India, most people went to bed or about to go to bed, so got a good night's sleep. And for me, I noticed it that I was trying to send something on WhatsApp, and I said that something happened. It was not going through it, and which is, it can happen. You know, you are trying to connect to the server, and you know, that happens once in a while. You know, small glitches always happens. Nothing is perfect in this world. And but that kind of persisted. Then I knew something was not right. So, and I go to a website called Down Selector. I don't know if you know that website. You go to Down Selector. Down Selector basically monitors if big sites like Facebook or Google has done, and there people report it, and they just say big number. They will show like, you know, 5,000 people said they could not access it. You know, suddenly there's a big spike. So I knew something was you know, not right. So anyway, I thought that, you know, the time is right. So we're planning on a webinar today anyway. So I, you know, and our, I thought, like, I'm going to cover this topic a little bit. So you realize that with Facebook, as I said, WhatsApp was also down, and Instagram was down. And then, you know, then, so.
Somebody is trying to say something.
Oh, it's okay. It's not for us.
Okay. And so, and Oculus, I don't know how many have heard of Oculus. They do a VR headset. People play games and stuff like that. That also belongs to Facebook. Facebook bought Oculus a few years ago. Just a couple of quick statistics. About you know, almost close to 3 billion people on average use at least one of Facebook products, you know, so like WhatsApp or Instagram. And this is from June statistics. Obviously, the number is higher than that. And then what you find out is that I found out is that WhatsApp was bought by Facebook for, you know, I think several $1 billion. And then, and so, and believe it or not, it has been downloaded 6 billion times since then. and one quarter of that download is in India, and one quarter is in Latin America. Very, very popular. Yeah, I think in the US it's only about 4%, but 4% of a 6 billion is still a pretty large number, and then I just wanted to pick one small example to illustrate what happened with October 4th, just to kind of show you how it affects at the lower end of the economic strata. So this is Maria Elena Rivas. She is a Venezuelan migrant in Bogota, and she uses WhatsApp to take orders like snacks like empanadas. Now, I really like empanadas. I have been to South America, enjoyed it. And so then she said is that on that day, she could not sell any empanadas. Her business, she couldn't do anything with it. And obviously, there's much, much bigger issues. I just wanted to give you a sample of what it is there. So when the Facebook reported that, they have actually written up a couple of reports on it, they said it's a faulty configuration change. And then this is from another news report, basically said that you can read it, while the DNS failures could have caused the apps to go offline, Facebook, this thing is due to BGP route withdrawals precipitating the incident. So I put the word BGP route withdrawal in red, obviously, as you can see it. And so that's sort of where I'm going to talk about. And this is something, it's like under the hood, like a car. You don't think about it that something is doing what you are trying to do. You're like trying to drive a car. That's all you worry about. And something happened, right? So I'll cover that part more. So I wanted to start with a poem actually found in Facebook of all places after this event. And this is just to say, I have nulled the routes that were in the BGP configuration and which you were probably relying upon for everything. Forgive me, they were workable, so fragile and so incomprehensible. So I will try to see if I can make something comprehensible. That's part of my role today here. So let's start with a quick intro about when you want to receive a web page or a message on the internet, right? So I'll try to do I'm not very good at animation, but I tried something. Let's see, hopefully it works out. First thing first, any content, whether it's a web page or a video or message, what happens is broken down into a unit in internet we call it packets. So packets are small data units. It's about up to 1500 bytes roughly, typically. So let's say if you have something like 5000 bytes, it has to do 1500 times t, 4500. And then the last one will be just 500 bytes. So you kind of break it into 4 packets for a 500 bytes packets. Now you realize 1500 bytes is nothing compared to the pictures you take with your phone nowadays, right? A phone pictures are 5 meg, 10 meg, depending on the quality. But that's how the basic principle works. So then you want to know 2 things here. I have a little bit of animation and the sound here. The blue things are called routers. Think about those as a traffic light. And let's say you are a user, you are trying to access a page from a server, and it is broken down into those packets. So I don't know if you can hear the sounds, but I actually introduced sound. So what happened is that, as you can see, hopefully you can see my cursor, the router says that, okay, I'm going to have 2 ways to go. I'm going to send it this way. It goes there. This again has to make a decision, go this way or this way. It goes this way. And then it goes again, in this case, it only can go this way towards the destination. Sorry, destination means the user. And then finally it gets there. Now remember what I said, that it created into packets, right? The packets are smaller unit of data thing. So your phone, your laptop, your desktop, whatever you're using, what it has to do is that it has to reassemble before it displays to you. You don't realize that, but it is done all the time. There are beauties about trying to do it like these small packets, because you don't need what is called a really, really big pipe. It's like if you have a big pipe trying to fit something in there, which is bigger than that, you cannot fit it, right? Second thing is that second beauty of this is that it looks like the links that looks like there is basically um, looks like a look like a road where you have the cars driving through it. That means different connections are all sharing it, and each one is creating packets, and they're all mixed up. Think about like a different color cars going through the network. So this is the basic thing you needed. So I want to introduce the routers here. Those are the blue. So I'm going to kind of go into the router part related to the BGP. Good. All right. So so BGP stands for Border Gateway Protocol. Okay. So Border Gateway Protocol, I'm going to give you a little bit of background on that. So is basically what it happens is that the internet is actually, it's a connection of what is called a separate networks. Okay. Think of this as a different countries that is actually trying to talk to each other. And a simple analogy I can think about is as if it is different countries, and each country is, think about like a network, and as if United Nations is connecting all of them.
Excuse me.
Yes. Is there a question?
Okay.
All right.
Okay.
Yeah.
I just want to ask one question.
Yeah.
Like why it is called protocol? If you can just explain that as well.
Yeah. So a little bit, I have a couple of things here. And so in BGP Lango, what happens is that when you are talking between networks like a different countries I talked about, they have to have some agreement how they are going to flow information. So you may say that I'm going to carry your stuff, and this is how I'm going to carry it. So protocol is just another name for agreed upon rules. So you and I agree on it that Udipana, you're going to call me at 5 p.m. I say, okay, fine. So that's what we agreed on. If you call me at 4:55, you broke the rule. Got it? So that's called a protocol.
Yes.
Okay. So you call before. So anything in the computers, when you different things try to communicate, you have to have this sort of a rule to be able to understand and communicate that part of this, what it is, right? So with that, that's where this comes in. Now think about the countries connected by United Nations, but with some rules there. Okay. So I'm going to illustrate, I think I have a picture next one. So what I did, I picked a few countries in South America. And what I did was that I did something simple. Of course, you don't see all the actual map, but what I did that if a country shares border with another country, what I did was that I connected by a line or a link. So Colombia shares border with Brazil. Peru shares with Colombia like that. Oh, hang on, what happened? So and then you can see is that Panama is actually way off in Colombia out there. Okay, now let's think about this way. So let's say Panama wants to go to Brazil, as if you're driving a truck, and it can go to Colombia and then go directly to Brazil, or it can go to Colombia, then to Ecuador, to Peru, to Brazil. You got it? So then each of them basically agrees on how they are going to share this thing along the link or the line through the BGP protocol, sort of. Okay. So now what I did was that I added postal codes to it. So first I had the countries. You saw the country map, and you see that for two countries, for Panama and Brazil, I added to their postal codes. 0801 in Panama is that postal code for Panama City. And 1001 is, I think, Panama City East or something like that. In Brazil, I picked a couple of them, one in Sao Paulo and one in Porto Alegre. So you can see their country, the postal codes are different. The fact that it is different, don't pay attention to it. But there are two things you notice. One is the country entity. Then within the country, you have the postal codes. Okay, so to keep those two things in mind, and we'll see what we can actually, how we can relate it to BGP, how it works. So what I did now is that I took all the names of the countries off from the picture I have. And then what I did, I call, let's assume all of these are separate autonomous systems. All right. And then what happened in the context of BGP, each autonomous system is given an autonomous system number. It's everything is number. So you can request a number, you can an autonomous system number. So as if a country is requesting a number. And in fact, although it is not exactly the same thing, you know that with phone numbers, there is a country code, like India has a 91, US, actually it's not quite correct. US country code is 1, but it is also used by Canada and the Caribbean and whatnot. So it's not quite the same thing, but gives you the idea. So I then numbered it from AS1 all the way to AS6, and you can see all of these things there. Now what happened is that we want to talk about IP address. Okay, so many of you might have heard of IP address, and most of you are familiar, those who are familiar with IP addresses in the form of what is shown as a, this form is like 134.193.2.71, right? So what's the connection between the IP address and the autonomous system number? The autonomous system number is that it's like the country indicator, and IP address is more like a postal code that I showed you. All right. So having said that, there are two actually use of the IP address. A lot of people don't know that. We are mostly familiar with the first one, like my phone, my smartphone, my laptop, it gets an IP address. That looks like the number I showed you here, 134.193.2.71. All right, and then what you will realize is there is actually a second use of the IP address, which is what we call as an IP address block. It is like a block of IP addresses together, or group it. In the internet technical lingo, we call it IP prefix. Okay, and this is actually used for determining the routing table for routers. So let me go a little bit more into that. So IP address, I want to clarify that the examples I'm using, like the 134.193.2.71, those are all what is called IP version 4 addresses. Nowadays, version 6 addresses are used. Those are very ugly looking when you try to display it on a slide. So I'm going to stay with V4 so that it's easier to kind of understand that. So remember I said 134.193.2.71. It belongs to the IP address block called .00 after the first two numbers, 134.193. And by 00, basically I specified the block. And you saw I put a //16. 16 is basically indicates how many bits. So IP address block in a version 4 is 32 bits. So 134 and 193 comes from the first 16 bits. That's why it is called a prefix. And the rest is, if you like to call it like a postfix, is actually the address for the devices. And so when you say 16/16, there's a very clever way the blocking was done that you can actually do blocking at different bit boundaries. So I won't go into that detail, but I'm going to stay with /16 so that it's easier to explain in the slides I have. So similarly, let's say I have another address, 157.240.19.35. It belongs to the IP prefix 157.240.0.0, which is /16 there, right? So to give an analogy, again, going back to my postal code, so I picked a few pin codes from Guwahati, like 781.001, 781.002, like that. So if we try to kind of group it or block it together, we could sort of say that, like I put it in green color, that the 781 basically indicates all the block, the pin codes, postal codes in Guwahati region, right? What's the beauty from a routing point of view? The beauty is that if somebody who is trying to say, think about like that, from far away, they don't need to know the exact address actually. So that matters a lot in the internet, because you don't need the exact address when you're sending from far-flung places. You almost need to look at like the first few, the prefix first is good enough, 781. And then you let, when it gets to like Guwahati, let it actually do rest of the routing for sending it to 781.0.0.1. And then almost like the way postal clerk delivers your mail, you can think about the next thing. That's how the apps actually deliver it to your different thing, whether you are trying to do a service like email or you're trying to do web. So you got the idea of the address. And feel free to ask some question through the chat box. I'm not monitoring the chat box. So if you do type something in the chat box, Udipana will read it to me. So
no, I have actually two questions from the previous slides.
Okay.
The first is about the autonomous system. Are they connected in the internet geographically like countries? That is my first question. And second is, why do you need to think about two ways for the IP addresses?
So let's say, so here is the picture again. So this is the picture. Obviously, I removed the name of the countries and put the autonomous system. The interesting thing and the funny thing is that they are not geographically connected. This is where it is very, very different. You can have an autonomous system and you can be connected in California with the same autonomous system. You can connect it in India in different ways. So, but what is important is that whatever I talk about the postal order or IP address block, that belongs to you. You can announce from wherever you want to. You still have to do a physical connection somewhere, but you are allowed to connect. So it's kind of a very warped way to look at the autonomous system, but it's very difficult to show it in a picture. So I usually kind of lay it like a plain paper to be able to do it. The second question was, can you repeat the second question again? What the question was?
Okay. The
something
second
about
question was, why do you need to think about two ways for the IP addresses? That was my second question.
Yeah, so what happened is that this number 157.240, hopefully you can see the cursor in AS number 6. Yes. That one is, I think the example was 19.35. So actually what happens is that the number with everything detail is really your device number. Like I think about your phone, gets external IP address. When you connect to your cellular provider at home through Wi-Fi, you get an address. But what happened is that if you try to do routing based on that address, it's a big problem. Why? There are 32 bits in the address for the IPv4. So, and then if you do the simple combinatorics, it's 2 to the power 32. 2 to the power 32 is a huge number. Huge means really, really huge. Okay, so when you do like on the first 16 bit, it is only 2 to the power 16. So 2 to the power 16 is 65,000, roughly about 65,000. That's a much smaller number than the millions and billions you go. So when you route it, for a routing purpose, you just need to look at that information for routing purpose. For the end device part, it is needed, but for that part, it is not needed. So what it does is a router on a network, even though you have all the address, it says that I'm only going to look at this part because I don't care for my part, I only care the first 16 bits. Rest doesn't matter to me. That's why it's a very crafty and a very beautiful way, use the same device address, same address for two purposes. And one is for the end user, one is for the routing purpose. Hopefully it helped to clarify a little bit that part. Okay, good. So we are good with that. So let me go a couple of more things I want to highlight on this slide. We have the AS.
So if you don't mind, would you like to address one more question? We have one more question in our chat box.
Sure.
So she's asking, what if similar packets are delivered from two different users to the same destination? How is it identified? Is it related to IP header?
Okay, so let's say my phone, I don't know if you can see my phone, and I'm doing two things. Many of us do two things, right? At the same time. So it is like that. So what happened is that IP address only identifies the device. Okay, so that's the the number like 150, that I showed you. But what happens is that there's another thing with for delivery purpose. It's almost like when I remember, that's why I like to always use the postal code analogy, because postal code is not enough to deliver to your home. Home, what you need an address. You need to address that whatever, you might have I'll tell you my address and home here, 4009 West 100 Terrace. You need the street address to get there. Even then, it is not enough. Maybe it is for your sister or your brother in your home, right? So once it gets to your postal clerk delivers at your mailbox, one of you said, hey, it is for you or that. So what happened is that there's a little bit of more information that is needed. And I'm not covering it here. It is called a port number. Port number is basically another extension of the address space without having to worry about it. Only the device takes care of delivering to depending on whether you are accessing a web page from one browser tab or another browser tab, or you're communicating with something on a WhatsApp at the same time. So that's how it can take care of that part. Hopefully that helps you to kind of understand that part of it.
Can the packets for the same web page take a different part? Like, don't we have to request a page first? Suppose
Yes,
on my mobile, the page shows up right away. Did I do anything?
Yeah, so actually, so when I request a page, theoretically, it can take different paths to get to your device, but in practice, all like let me quickly go back to that slide for a second. This picture, all of these things, when I had this package here, they are all actually takes on the same path, because what happened is it makes it more efficient to deliver it. And so the routers are actually a little bit smarter. It says, hey, this packet number 1 is for this user. I know this user, or this device rather, I should say it. And so I'm going to put it on this route. And the packet number 2 comes and it said, hey, I send one for this way. I'm going to do also on the same path. So then they go like a train, like I call it like a packet train, to get there. And that makes it more efficient. To make it happen, routers are actually very, very smart, and it has to be a very, very fancy, high-end, really computers with a very, sophisticated chip, and does a lot of software lookup to be able to quickly look it up and send it out. So for you and me, when we get the page, it looks like it came instantaneously, but it is because of the magic that is done in the core of the network. And if that was not done, it would not happen in that way. So it could happen that we're staying with this picture, you actually request a WhatsApp message coming from the same, the cloud there, that may send this bottom part, go this way and come here. So depending on each separate session or request, it can actually it is possible to take a different path. But within the same particular session, for particular page you request, all of the packets in practice takes the exact same path for efficiency purpose. So there's a lot more details into it. I will skip the details, but kind of try to communicate the idea. All right, so let me see where I was. Okay, good. All right, I was here. So I then, for a routing purpose, I need to only worry about the IP prefix and so our IP address block, and that's where the BGP route withdrawal comes to. So let me get to that in a second. So BGP uses 2 announcers. This goes to Uddipana's earlier question about the protocol or the rule. There are one important rule about BGP is that you are going to announce an IP prefix, or you can actually withdraw it. So let's start with the prefix announcement. What happens is that when I announce the prefix, like 157.240.0.0/16, I tag the AS number to it, okay? And then I send it to my neighbor, because I can only communicate to my neighboring AS number, which happens to be AS2. Bear with me for a second. I'm going to show the picture again. And then when AS2 gets it, what AS2 does, it tags each AS number to forward it to the next AS number. So for the one that was originated in AS6, it's going to look like this. You have this part of the IP prefix, AS number 6, AS number 2. I put a, for illustration purpose, I put a colon because that's easy to kind of explain it. And so that way, similarly, the other address, which is 134.193, which was in AS number 1, is going to tag the AS number 1 and announce it to the other one. So let's go to the picture here again. So what I did was that it's a AS6 is going to announce it, is going to tag that number, and it's going to send it to AS2. Now look at AS2. AS2 is connected to what? AS7, AS3, and AS1. So it's going to tag that one, same thing, and it's going to announce on all of those three. You got it? And eventually it's like a propagating that information, and that gets to AS1, where you are sitting there, for example. All right, so I'm going to go back to my country map now. Okay, so let's say, because it'll be easier to see in terms of what it is. Remember I said the Panama City 0801. So I'm going to, like, as if tag the word Panama next to it. I'm going to announce it to Colombia. Got it? And Colombia gets it and tags it to their name, to country name, to Ecuador, to Peru, and to Brazil. So I only showed it here for Peru. Peru, what is Peru going to do? It's going to tag its name. It's going to announce it to Chile, Bolivia, and to Brazil. Okay, so if you kind of look at it there, let's say you are sitting in Brazil. I said, I want to go to Panama, this particular postal address. Okay, how do I go there? You'll find out that you are going to see two routes. You're going to see one route. You always read it from right to left, sitting at Brazil. I said, my next one is either Colombia to Panama, or I can actually see another route from me to Peru, to Colombia to Panama. So I see two routes, right? And then you have to make a decision. So that decision, you say that, hey, I have two routes. I'm going to take the shortest hop route. That is, I'm going to do the Brazil to Colombia to Panama instead of going through Brazil to Peru to Colombia to Panama. I mean, it's a simple thing like hopping through it, and it's a very simple rule it does. What I want to make it clear, that decision about the deciding what will be the shortest path is not done when you request the web page. It is actually done ahead of time. It's done maybe 10 minutes ago, half an hour ago, and they stick to that path. They don't change the path. Okay, you want to go from Brazil to Panama, we're going to stay with that. So when you request a page, that's why it is efficient, because you are not doing the routing at the time on demand when your page. Otherwise, your page won't get there, because you're like asking your friend that, hey, how do I get there? Your friend responds back to you, and it's going to get delayed, and you are not going to be able to, get to the destination. So, and this is also why the division of the IP address in two ways is extremely important, because one is for the device addresses, other is for routing purpose. So to kind of recap it, for routing purpose, you do those announcements periodically, and you update maybe every 10 minutes, sometimes maybe an hour, every hour or so. Could be a couple of hours if nothing changes, but your device addresses thing then can take those paths to be able to get there. Okay, so now kind of I want to kind of tell what very interesting. BGP is like countries; they are policy driven. They get to, countries get mad with each other sometimes with their neighbors. And that's why I picked, just to play it safe, I picked countries in South America. Let's say Colombia and Ecuador decided that they don't want to talk to each other for whatever reason. So what happened is that Colombia won't even tell Ecuador that it received the postal code 0801 from Panama. So Ecuador has no way of knowing it. Only way Ecuador might know it because if Peru decides to announce to Ecuador. So Ecuador has no idea, no option except for to send it. If they want to send it to something to Panama, you have to send it like that. This, by the way, happens with sometimes getting a visa for going to certain countries, because you have no agreement, you have to go to another country, go there. It's very much like that. but this is all basically coded in the BGP protocol. So I am trying to give you a very simplified way to explain what it is, but it actually has a lot more details into it in terms of what you are trying to kind of restrict it if you needed it. And sometimes you do those restriction for good reasons you are trying to do it. You probably want, because what I didn't show is that how big the roads are. Maybe the roads through Colombia to Ecuador to Peru is actually very thin, like a very small, we count in megabit per second or 2 gigabit per second. If small, it is favorable. It's possible the Ecuador says, I don't want anything. I mean, Colombia says, I don't want that to go this way from a traffic point of view, because road, the size matters. You can go on a highway much faster than on a smaller road, right? So although I am using a line to direct it, it doesn't say how fat or big that it is, right? So there are good reasons to actually be able to do this sort of a policy. And this thing itself is a art in itself, and you get to know a lot more detail about it. Now let's talk about withdrawal, right? Remember I said BGP route withdrawal? So simply it's exactly similar to the announce. You can actually say that, hey, yep, go ahead.
So before going to the next slide, if I can ask you, like any other example of policy used by the BGP routing? I'm just curious.
Yeah, so BGP routing is the policy would be that remember there are two postal codes I showed it there. Okay, 0801, 1001. That it doesn't mean that it has to announce all of them. So let's look at from the point of view of Brazil. I have 3 of them. I can do a filter based on one of the postal address. I will announce this one 054160001. Actually, it's a postal code for one of my friends in Brazil. That's why I picked it. And I might announce it to Colombia, to Peru, to Bolivia, to Argentina. But the second one, I may only announce it to Peru. So you can have the policy you can do at different level. Does it help to kind of give you, and for a variety of reasons, say, okay, this one is maybe, remember, I am not showing how the internal network of Brazil it is, right? Maybe it is in a very remote area. So you want to use certain policies to control at that level of information, okay? And the other reasons you do it is that sometimes, although I'm showing only one, like a line here between Colombia and Brazil, in practice, they're actually almost like a parallel lines there. As if like if you're Colombia and Brazil, they're connected in different, transfer points in the, between cities like a road, you have to cross through it. So sometimes you prefer between them, which one you actually want to go on compared to other, because the one is a highway versus a smaller road, similar example. So you can use policies at that level also. So does it help to kind of give an idea there?
Yes.
Okay.
I got it now.
Hello.
So, yeah, go ahead.
Hi, sir. I want to say something. Sir, when I find shortest path in reach to Panama to Brazil, like Colombia, when after this system is offline, to how to reach this path, it is find again new path to reach Brazil and what?
Okay, so that's where I need to talk about withdrawal first. Okay, so bear with me for the next few slides, and then I will tell you about that in a second. Good. So
okay.
Very good question. So withdrawal is that sometimes it is no longer available. So an IP address block there are very variety of reasons it is not available. Although I'm using the postal code ideas, actually there's a little bit more to it. You can, I think my other map might be a little bit better here. Okay. So actually, although I said that a IPA prefix is associated with AS number, this is not for the, until this whole world disappears from millions of years from now. It is actually for a duration of time when you actually pay that autonomous system to carry that IP address block for a certain, and usually those are 1 year to 4 years or 3 years, but it can change because of business reasons. So you can actually move this address to another one. Keep that thought with you. I'll come back to that. That's an example of a potentially where you want to withdraw it. So what I want to do here, so you want to make it no longer available, sometimes temporarily. So what happened is that you wanted to announce it exactly like by tagging the AS number to your neighbor saying, hey, it's like Uddipana telling me that I'm going to go to sleep now, don't bother me. And I tell you that don't bother Uddipana because she went to bed, and you tell her friend, don't bother Uddipana. So along the path, the person at the end knows that, okay, I don't need to bother Uddipana at all. So that's like a withdrawal, and they know the path, how to go to which person to go to the last one, right? So that's the idea of the BGP withdrawal. So let's go to this picture again. So I have the address. Let's say for some reason, AS6 says that I want to withdraw this IP prefix. It tells AS2. Remember, it was already propagated, let's say 2 hours ago or whatever. AS2 has to now tell, like the way I gave you example with Uddipana and you, that I tell AS7, AS3, and AS1, it says that it's not available anymore. So now what happened? AS1, I'm sitting here, I need to go to this one. It says that I learned from AS2 and AS3 that it's not available. I cannot do anything about it. And this may be propagated to AS4, AS all the way to here, AS1. AS1, when I try to request a page, is that which happens to reside in IP prefix here, it immediately says it's not available. It doesn't even go try all the way. It saves all the requests going into the network, like, junk basically, and immediately said it's not available.
So,
right.
So was that the time we have tried to open Facebook during the outage? I mean, like at the time that withdrawal happened, you were saying?
Exactly, correct. So what happened is that this thing, this is, by the way, this is address block is not by AS number is for illustration. The address block belongs to actually Facebook. This address block belongs to my university here. So I'm illustrating with those address blocks purposefully. And by the way, this is from the address block I see from my computer for Facebook. So that's the one I use it there. So what happened is there's a router here, BGP router here on this thing. They were doing some actually fixes. So fixes, what happened is, look, everything is, everything is live, right? So they still have to change something. Maybe the router is 10 years old. You got a new super duper more fancy router. You have to like swap it, right? It's almost like a swapping it. You put this one in and that one work. So you have to do certain thing during that time. Now, I'm not saying that exactly what they did. I'm just kind of illustrating the idea that a computer doesn't stay there forever, or your data you can access it, but it's not on the same drive all the time on the Facebook server. So what happened is that they can actually then, when they're trying to do it, they said, I'm going to withdraw it for a very short amount of time. So the problem with the withdrawal and this thing is that if it is just a real legitimate withdrawal, it's fine. If it is some server which is very unknown, it doesn't affect the internet. But if it is something like Facebook or Google, if it withdraws an address block, everybody gets to know in a very short amount of time. But users don't know that. Users are going to keep trying it to get there and say that I'm not getting it. Maybe I need to refresh the page. Maybe I do it again. You hit the send button again or whatever. You keep trying it. This is called, I call it adding fuel to fire, because the network is already not being able to serve it. You are just kind of sending requests again and again because you thought maybe I didn't do something right? So it causes more secondary impact closer to your part in the network.
I mean, why like it has taken so much of time, like 6 hours of time to fix it?
This is actually fixable in a very short amount of time. Maybe my next slide. Okay, let me talk about that, and I have a slide on that and answer your question in a second. So the one thing is that the cause is not always clear, because the protocol says that you can withdraw a route. And sometimes what happened is that maybe this physical link is down, the road got cut down. AS2 is always periodically reported that, hey, this IP prefix is available, I am reporting to you, we're good. And let's say you don't hear it for 15 minutes, AS2 doesn't hear it. AS2 said that I don't hear this IP prefix from AS6, something must have happened. So AS2 takes the responsibility to tell others that this address block is not available anymore. So it's a legitimate reason. So whether it's a failure or disagreement, what, you don't know the actual cause why actually, because protocol allows you to have that. So, okay, I'm going to skip that. I'll come back to that part later. Okay, so I want to first clarify Facebook has its own AS number, and it did a configuration change at its BGP router. It's for a maintenance purpose. And then what happened? AS2 generated withdraw message for this IP prefix, not hearing for a while. And then what happened is that you guys are all sitting there trying to access it, and you are not being able to access it. Now to go to Udipana's question, why it took 6 hours, is that actually these configurations are, you can actually fix it fairly quickly by advertising it, by giving a few commands and things like that. So I don't know if somebody actually swapped the router or something else happened remotely. I do not know, because sometimes you do the remotely, you can access it. And why is it remote? Why the delay? It's all has to do with COVID. So because of COVID-19 pandemic, every Facebook employee was working pretty much, from remotely, right? So
Yes.
now what happened? So you're using the same cloud data center for IT staff to access remotely, right? And the IT staff, and they could not access it. That means they even could not communicate with another IT staff. It's like me not being able to communicate with Dipana. Both of us work for the same company. So I need to now communicate. So then apparently they try to use a third party to communicate, like maybe use a Slack. I don't know if you're familiar with Slack, for example, to communicate, but or some other communication tool, maybe Signal, for example. But some of them uses login with Facebook option. Okay, so if you have a login with Facebook option, what happened? Facebook is already down. You cannot get the login information back to you. You are not being able to communicate.
So this is another challenge of remote working.
Exactly. And the last one is more interesting, actually. So when they realized they could not access remotely, there were some obviously staff in Facebook cloud data center. They drove down, and their ID, they tried to use it to access the building. Guess what? ID also used the internet to connect to do that. So their IDs were with the internal system, and they could not authenticate, and so they could not get into the building. So I do not know if they actually broke down a door or anything to get into the cloud data center. This is what actually happened, why it ended up taking much longer than if somebody was there. I'm pretty sure yeah, go ahead.
I have just like in a previous slides, it was showing that that autonomous system, I thought that Facebook uses cloud, and how is it cloud related to the autonomous system? If you can just explain a bit about it.
Okay, very good. So what happened is that, remember I showed this is a Facebook one IP address. I showed it for one server. Facebook, the autonomous system, although for illustration purpose, I use the country example. Pretty much any company can request an autonomous system. Not only a company, a university can request an autonomous system. My university has an autonomous system number 3390. Anybody can use it. Okay, anybody means not a person. I mean, entity can use it. So although I'm showing it here with AS number 6, as you assume that's for autonomous system number for Facebook. So then what happened is that Facebook has an autonomous system number to get out from their part. So physically, what does it mean? Facebook, for a service purpose, or WhatsApp, they are all, we use the word called cloud. So cloud is a big data center, basically. Big data center means it's a stack and stacks of computer. I call it like a pizza boxes. You slide it up and, I think I have a picture somewhere later. I'll show it to you. They're all connected. Then there is a way to get out. And that whole entity is now your autonomous system number. Does it make sense? So
Yes.
So anybody can request an autonomous system number. To kind of recap it, any means an entity can request it. It could be a university, it would be a company or a government. Anybody can request it. And then you can use it for the purpose or setup you want to do it for what you are trying to do it. Like I'm using, say, my university, we have an autonomous system number, and that one, we only use it very locally for just this address, 134.193. Although I use AS1, actually our autonomous system number is, AS number is 3390. So I know that, right? So does it help? So you kind of got the idea. So I'm giving a very high level way to be able to kind of look at the autonomous system, and then you actually, now I want to tell you that Facebook doesn't have just one data center. It has a multiple different data center, physically, geographically different location. And that's where, although I use a geographic way to illustrate the point, essentially they can connect to the rest of the internet at different places by using the same autonomous system number, okay? But their entry points, for variety of purpose, they do it in a certain way so that it is easier for them to manage it. And that probably caused certain issues for them to be able to take care of that. I think this is a learning experience for all of them. By the way, Facebook data center is
But why Facebook didn't think about these possibilities before? I mean, when they're a big company, right? Big cloud-based. So,
yes, I mean, this is one of the things you didn't think about, because most cases, this kind of, I'm pretty sure they have done this configuration type update, even remotely in the last year and a half. But maybe they gave a slightly different command to catch it after right there. That it's almost like a simple human error. So that can happen. So that you don't worry about that, because it's fairly easily manageable. Now that it has happened, so you are going to be much different ways you are going to manage those kind of a things. So how to access it? It's one of this is hindsight. It is very easy to kind of say that, okay, they should have done it, but I'm not surprised this happened. So, and I'm going to give you a quick example in the next few minutes about what happened to a couple of examples with the Google outage from almost 10 years ago. All right.
It happened yesterday also for like around, I think, 1 hour, but I was sleeping, so I didn't experience it. But for our actually audience, if you can just in simple language, if I ask you to explain actually that so Facebook, WhatsApp, Instagram, three of these apps stopped down at the same time.
Correct.
So what is the reason that three of the applications stopped down at the same time? It is because of the IP address, because of the automation system, cloud. What could be the reason?
Yeah, so they are all belongs to the same, let's say the same, that could be all belong to the same cloud data center. They could all belong to the same autonomous system. I have not verified it if they do belong to. So you're going to, and if it is the same data center, even if you have a different autonomous system number, you're going out part or whatever. I think it is probably the same one that they actually were under the same autonomous system. And so when you are trying to do become like a withdrawal of a route for the neighboring autonomous system, it basically got up all the IP address for the Facebook, for Instagram, for WhatsApp, for Oculus, all of the different IP address prefixes they have, all of them are basically suddenly said it disappeared from the internet. And that's why this sort of thing actually happened. Does it help? Okay.
Got it. Yes.
Okay. Yeah.
So we have one more question in our chat box.
Yes.
Is it a match network when it comes to using an alternate path when a particular path is unavailable for delivering packets.
Yeah, so alternate path can happen. Let's say now forget about the failure for AS6 here. Let's say we were using shortest path from AS1 to AS2 to AS6, right? Let's say this link actually went down. What happens is, remember I said that we announce it. When you announce it, what it does that AS1 stores the alternate path in their routing table, saying that I have another way to go to AS3 to AS2 to AS6. So it stores it, but it doesn't use it until this goes down. This link goes down. Then it said, oh, I'm going to switch to the next one, and immediately starts using that one. So that actually works because AS1 stores the alternate path in the routing table. Make sense? Because I can say it can do even more, AS1 to AS4 to AS3 to AS2, AS6, because those are also announced. AS1 knows about 3 to 4 paths. Okay, so then the switching part is very, very easy when one of them goes down. So one link failure is not necessarily problem. Problem is, that's why I purposefully use Panama to example to illustrate the Facebook, because this is called a stub in the network context, where you say, because they're not connected to anybody else, they're connected to only AS2 here. And so one thing would be, to answer Buddhipana your question, you want to have multiple connections to multiple different autonomous systems, because if there is a withdrawal problem here, you can actually maybe take care of it this way, because these are logical way you can sort of, all the physical fibers are connected, you can actually take care of it there.
Also, right. How do you see the monetary loss of Facebook? Facebook lost around $100 million, I believe, during the outage.
It is probably, enormous. It's unbelievable, because their business, all the services, everything depends on it, from anything, all the ads and everything. They make a lot of money from ads, so everything depends on it, so they lost a lot. Not only that, all the secondary thing, like what you and I do, we could not do business. I picked a small example for this migrant worker from Venezuela to illustrate that person couldn't do. So you can now add up those numbers. It's enormous. It's so it's bad, but
is our data at risk because of this outage?
No, the data is not at risk, because it's still sitting in your the cloud data center, because data is not touched at all. It's just that router is where the
some people are thinking it's a cyber attack.
No,
so
it's not a cyber attack.
Right?
It's not a cyber
we
attack.
have a question in the chat box also.
No,
so it's not a cyber attack, right?
Absolutely,
and our
not.
data is safe.
Data is safe. Cyber attack, Facebook or any Google or everybody, they have a lot more shields, I would call it, to take care of it. That's actually a much well understood problem. And so you take many ways to defend that and take care of that part. So it is not actually, even the remotely accessing the routers is very, very restricted. And that may have also made it more difficult for Facebook to do it, because maybe they only allow two or three people to access it, because it is, they want, because that's your pipeline, so to everything that is connected. So
it's a very critical data.
It's a very critical, the parts where only few people have access and stuff like that. So, I don't think Mark Zuckerberg has access to the BGP router. I can assure you that. So, and you might have access to other things. So even that is very limited.
For this company, data security is their primary and major concern.
Exactly.
So I'm sure they take care of it.
Exactly. And they have different IT groups take care of those different things. These IT group who take up our router, those are very specially, really, really highly paid, because there are not too many who understand all the policy issues and everything that can go, to be very careful. Even then, errors can happen. And so different groups takes care of different part of what it is goes on there. All right, we're almost getting.
Sir,
Yep.
I have a question.
Yeah.
Where does Facebook and WhatsApp saves all the data? It's tons of data, millions of MB of data.
Most of them in the cloud storage, but most of them in California. But they also have now, storage in different places around the world. I don't have a map of all of them. I do have a map of the Google's cloud thing, but I don't have it on a slide to show it to you. So let me quickly cover, do you have another question? I want to quickly cover these two very interesting example to wrap it up. Any other questions related to the Facebook situation? And I can also answer at the end after I cover these other outage examples. Okay. All right, so let's take that. There are two examples that YouTube went offline in 2008. Many of you were probably pretty young and didn't know that. And so the Google, something happened in 2012. So let me kind of, this is called slightly different. It's called an IP prefix hijacking. Now hijacking, we use the term, technically we use the term hijacking, but it is actually unintentional. All right, so I cannot go into all of the details, but let me kind of give you a little bit of a high level idea about what happens. Remember I talked about the autonomous system? But there is also a hierarchy among autonomous systems. These are called, I put an arrow here. They call a, business term, they call it providers versus customer, the peers, between two the small circles, I showed it at that different level. And the lowest level of the autonomous system are called sibling peers. Now, what sibling pair, there's a rule there is that even if I know of an IP prefix that comes for me from this one, I'm not supposed to announce this up the hierarchy. This is called Lixin Gao. Lixin is a good friend of mine. Lixin Gao's value-free property, she calls it. So with that, basically says that I may know an address from IP prefix from here. I can announce it here, that will announce it to here. When I know it, I'm not going to announce it to here. That's why I put a dotted line here, although we are peers and we share different things. The problem is that if I know it here, I can announce it this way. That's exactly, without going into the detail, what happened is that value-free property, certain autonomous system paths are not allowed. I kind of crossed it off and I won't go into the detail of it, but basically trust me that you cannot go up like this way. You can go down like this way, from go up and down, but you cannot go up there. The reason it's called a valley-free, it's like as if you're going down and up. That's called a valley-free. That means it's like a valley and going up there. That is not actually allowable. So this is called the Pakistan YouTube hijack example from 2008. What happened was that Pakistan Telecom issued a thing telling everybody in Pakistan that you need to actually take off a particular YouTube video. And because that YouTube video was, I think, shown, somebody from Denmark did it, and it was blasphemic about the Islamic religion. They didn't want anybody in the Pakistan to be able to see it. So Pakistan Telecom Authority that issued a requirement, and because of that, then Pakistan Telecom said that they had a very short amount of time. And I personally believe they did a brilliant move, how they actually tried to take care of it when I saw what they did. What they did is that, again, I won't go into a lot of details. They basically created a fake, this is YouTube's address here. They created a fake address for YouTube temporarily so that anybody in Pakistan that is requesting, they're only going to stay within there because they're not going to go all the way out to the rest of the network. So that was the easy part of it. What was the hard part? By mistake, they announced it. Remember the value-free property? They announced it to PCCW, which is the largest provider in Hong Kong, actually, the AS number 3491. PCCW trusted that this is probably the right announce. It started propagating to the rest of the world. So the rest of the world, what happened is that there's more detail in there, started sending every request instead to the YouTube's not everywhere, but a lot of the part of the internet started sending traffic to YouTube. YouTube noticed that it didn't got completely outage, that their traffic dropped significantly, like 10 or 15% from what they typically see in a very short window of time. They have no idea what has happened. And so this is outage basically really impacted because a lot of traffic going to Pakistan, or requests rather, to watch any YouTube video, and they were not able to actually serve any of them. So where is the problem? Problem was the PCCW, although Pakistan Telecom by mistake announced this specific address for YouTube, the IP prefix, PCCW should not have announced it. That's another of the policy thing that I would want to ask about, that sometimes you get it from a lower in your hierarchy of autonomous system. You don't announce it because it can create this sort of a alternate path. Those are not desirable on the internet. So that's a very high level idea about it. Again, I said that what Pakistan Telecom actually do was a brilliant proof how to create this bogus BGP entry, but it just had a knock-on effect that caused this bad situation. So Google outage. So Google outage, this is 2012, and I actually created, this is my slide from when I created it. I had a undergraduate student doing research with me, Kelsey Leftwich. She wanted to know, said that, tell me exactly what happened. So this is very similar thing. This is Google's AS number is 151694. This is their IP prefix block that they have. The Murator is their AS. This is connected, and they are connected to, then connected to this one. So what happened is that I didn't show it. Google is connected to multiple different places. Google, cannot see it. By for whatever reason, they announce it to Murator, which is actually at the bottom of the stack in terms of the AS hierarchy. They should not have announced it to the rest of them. When they announced it to the rest of them, anybody sitting here, they said, this is a shorter path for me to go to Google. They started actually sending it out this way. And that caused a Google outage for about two hours. So the configuration mistake, although as much as we know it, sometimes it happened for a variety of different reasons because they didn't put the, what I call is the export-import filters very well. And so that can actually cause that. So I wanted to give you a couple of different examples because of the what my good friend Jen Rexford from Princeton University called it BGP behaving badly. Whether not necessarily intentionally, but that can cause different things there. So I talk about outage for different, I'll give you a couple of different things, the role of BGP. BGP is like a glue that connects the internet, but it has a, as you can some fragility in it. It was designed 30 years back on a piece of napkin. The guy who designed is a brilliant guy, Jakob Rector, and I think Russ, and I forgot the second person did. And they, and so because they needed to connect the internet between different autonomous systems at that point, they came up with this thing, and then more things were added later on. So again, I will end up with the poem. I put it at the beginning, and I'm going to stop it here. All right. Are there any other questions?
Yes. So if anyone have any questions, they can either type it in the chat box and unmute themselves and ask.
Okay. Somebody asked, you asked, I think, Udipana, about the cloud data center. So here's a picture. I'm showing it to you. Well, the one example. It's like the cloud is not just one machine. This may be this little thing. I don't know if you can see my cursor. This is one server. This is another server. They have a bunch of different servers. When your request comes into, let's say this is the door, BGP router is sitting there, comes in, it routes to all this stack up thing to go to here. Your request may go to this server. Your friend's request may go to the server here. A third one request to this one, because they want to be able to serve as efficiently as possible. And these things are wires that is connecting in the cable can carry gigabit to the terabits per amount of data within even data center right now. So they can move up as soon as this comes in. Again, there's actually not one single BGP router. It gets a lot more complicated, but I'm kind of trying to give you an idea about how the gateway actually works from a conceptual point of view to take care of that.
Okay, so there is one question that can NDN routers solve the problem?
Sorry, can you repeat that again? What router?
Yeah, Vishal asked, can NDN routers solve the problem?
Yeah, so NDN, I believe you're referring to named data networking. So named data networking is a very different concept than how BGP works. Named data networking also has its own challenges. Among other things, that its lookup is going to be a lot less efficient than a typical router can do it, and that can slow something down. Second thing is that even for NDN, the routing protocol part is not actually fully fleshed out in terms of how it is going to work. So we don't know the answer to whether the NDN can actually really solve this kind of a problem at this point, at least at this scale of things. Small lab tests, I have, we can probably say, oh, this works. And this is exactly what we do in my routing class when I connect 3 routers and tell them to yank a cable and see if the tables got updated. They can actually test it out and everything, right? So they can do that. But you go to a large thing, sometimes a small this thing, what is called the butterfly effect. A butterfly effect is a term that comes from climate, that a butterfly can flip somewhere, that it can cause some other problem in another part of the world.
I have a question.
Yes.
We are going more like a online thing, more of like virtual thing we are going on. But even though we say it, we are doing it virtual, but it's actually not virtual, right? There is something physically present that the data center to keep the data. Do you think in future, are we going to have a true virtual?
No, it's not possible. There's nothing called a true virtual. Eventually something has to be connected to something, whether it is a wired connection or a wireless, like, I'm connected through my Wi-Fi to my home gateway, right? So still I'm connected. It's physical in that sense of the word, right? So yeah, yeah, by the way, Zoom has their own data center. For example, they use it for what I'm just trying to do with you. They have, I didn't check it. I'm pretty sure they have their own autonomous system number to route it. I know that when during COVID, Zoom's popularity suddenly hugely increased. They ran out of their capacity in their data center. So then they lease capacity from Amazon Web Services, where actually, Uddipana works, the company, the web services to lease capacity. So you can, it's a business, right? Everything is a business eventually. So you can then set up those connectivity, announce the autonomous system number from that block, from the lease capacity of the servers and whatnot to the rest of the world.
Hello.
I think no people. Yeah, somebody has a question.
Hello, sir.
Yeah.
Yes, go ahead.
Can we make smaller and smaller size of data center in future? It is possible or not?
This is a very good question, right? So smaller means everything is getting smaller in certain ways. But depends on how we make more improving down the food chain. By that means that in material sciences, one of the biggest challenge is that obviously when you create the chips, you have to make improvement in physics to be able to take care of the conductions that you learn in physics in maybe your higher secondary, right? So to be able to reduce the gap, only then you make a smaller thing. You want to be able to cut down the space for the motherboard and everything to be able to fit into smaller things. All of this thing needs a lot of other scientific development to be able to get there maybe 5 to 10 to 20 years from now. What we're able to do today is the improvement in science that has happened from physics to material science in the last 30, 40 years, that we are seeing the fruit of that today. So what it is being done, we're not going to see probably another 20, 30, 40 years from now. That's why I really enjoy science, because the impact is enormous down the road to be able to reduce the size of a data center like this. I mean, this is a great thought, right? So you want to think about, how do I reduce the space? Not from a physics point of view, from the material science point of view, can we do something differently? From a chip design point of view. So all of those things come into the picture. Very, very good question.
No, I remember when I first learned about this cloud storage.
Yes.
Probably I spent 1 week watching these videos at on YouTube at night. After office, I used to come home and watch these videos. So yeah, and one person is saying, I think Mohit is saying that the cloud word itself is misleading.
It is. It is absolutely misleading, but there is no other word to explain it. It's basically, so it's out in the cloud. It's somewhere there. It's just easy way to explain to rest the general population. That's where the term cloud become popular. We use 2 different words. One is that called a data center. When I teach my classes, I use the word data center because this is called a data center. That's really what it is. Second thing, data center is not one server. This is actually a data center network. It's already a network because all are connected here. So they're also doing routing from this, let's say there's a BGP router here to send it to here, to send it to here. They have to, but this routing information, they don't have to send it outside the data center. But Facebook data center is an enormous thing. How they actually route internally from access point or the gateway to any of the servers and tracking and stuff like that. So that's a topic in itself. You want to learn a lot about it. It's a fascinating topic, actually.
Maybe, sir, I have a quick question.
Yes, Praktim, go ahead.
So all these data centers and servers, they create an enormous amount of heat.
Yes. Okay.
So I have heard that I saw some news that Facebook was trying to relocate some of the data centers to some colder countries, or I also heard that Google was trying to put some servers in the deep sea to tackle this problem. Do you know anything about this?
Absolutely. It first happened to Google even 10-15 years back when they started providing. So we are all contributing to you. When you do a Google search, you're using electricity somewhere in a data center. Collectively, think about billions of people requesting Google, search, for example. Google was the first one sort of who actually reported it. And I remember it is that when it came up, Google said that at that time, their electricity cost was, I believe, was even more expensive than their hardware cost, if I remember how much they were paying money for all of the search that we were doing, if I remember it correctly. Now, if you and I buy a laptop, my laptop is more expensive than my electricity for using this for, let's say, this particular Zoom session I'm doing right now, right? So the economics completely changes when you go to this one, where the cost of the electricity becomes much, much higher, or significant part of your budget. So that's where Google started doing very interesting trick. They started shopping where they wanted to set up data center, where they will get a better price for electricity bills. And they made agreement with different part of the United States, different countries. And as you said right now, Rock Team, that they actually are looking different ways to be able to do it. And this is a challenge for any of the big data center providers, that they always look for other ways to reduce cost and reduce the impact on the environment, for example. And so, yeah, there are those are other interesting research things somebody can explore, because of a challenge comes from all of us using Facebook, WhatsApp, Google search and whatnot. So,
Thank you.
I think people are now more focused on cryptocurrency. I think that is one big risk. Recently, we have seen that if the internet goes down, then one day, if we rely on cryptocurrency, then we will be penniless, right?
I won't say you will be penniless, because the data is stored somewhere. You won't be able to access it. The value might go down temporarily, potentially. I'm not in the speculation business myself, so yeah, that can. But the information will be stored. But there's a different part to the cryptocurrency. It has also cryptocurrency. The mining part is actually very, very high electricity consuming, and so they also use data center services to be able to take care of it. And so there are other implications because of that part of it. So at the end of the day, nothing is free, I guess. So so there is a cost somewhere in the system. So.
And to add what Rockteam has asked about the impact of this all data to environment, I think recently Microsoft has initiated a project to reduce the carbon dioxide, what they are emitting or emitted since 1995. They are now spending millions of dollars on carbon dioxide reductions. I don't know how they are going to do it, but I think they are investing on it, and there are a bunch of scientists, mostly they're working on carbon dioxide reduction. So that will be interesting to see how they achieve that. I think by 2025 or 2030, I think they are going to do it.
Yeah, I mean, this is where, even companies like, although we think about like there are computer companies like Microsoft, Google, or Facebook, or Yahoo, they realize that there is a bigger problem because of the different sort of the cost. So they are hiring scientists in different domains, different fields, and you might not realize it. There is a really interesting opportunities coming up for if you're pursuing your passion is about learning about CO2 emission or whatever, right? So there are actually new fields, new areas rather, that you can actually apply your knowledge to be able to make impact. So if you have a passion, you want to follow your passion in terms of your interest. So. All right, are you good? Anything else?
Yes, I think there is a problem with our feedback form. It is not working for some people. So we will send you the feedback form link via email.
Right, correct. Great. Very good. All right. Thank you, everyone. Thank you, Udipana, for playing the host today. All right. Okay.
Yeah, thank you everyone for joining us, and please join our next webinars as well. We are expecting all of you. So thank you very much. Good night.
Okay. Bye.
Welcome, ma'am. Bye.
Bye. Bye, everyone.
All right.
Bye.